Hello everyone. So today we are going to solve this LeetCode problem, which is a special binary string. Okay. And what this problem says, let's see. It is a hard type of problem, but let's see what this problem says and what approach we can apply on it later. Okay. So this problem says that a specially binary string are binary string which follows the following two properties. What are these two properties? First one is the number of zeros are equal to the number of ones. Okay, the number of zeros are equal to the number of ones. Okay, and what it says secondly it says that every prefix of the binary string has at least as much ones as zeros. Means in any prefix number of ones should be greater than number of zeros. That what it says. Okay, and you are given a special binary string s, and this is our special binary string that we have given s. Okay, and what we have to return, we we have already given this special binary string. Now what we have to return, we have to check. Okay, move consist a move con we you are given a special binary string. A move consists of choosing two consecutive non-entry special substring of s and swapping them. The two strings are consecutive if the last character of the first string is exactly one index before the first character of the second. And we have to return the lexicographically largest resulting string possible after applying the mention operation on the string. Okay. So what it says that we have been given a special binary string, but we have to return another special binary string which is lexicographically largest. Means number of ones, if we see if more number of ones will come on the left side, then the string will automatically become greater. Okay, so that's what we have to check over here. What we have to check that it should be greater. Okay, means number of ones as many as possible we can put on the left side by using this operation, which says that we have to choose two consecutive special substrings and swap them to make this binary, which is another special binary string but lexicographically greater than the previous one. Okay, got it? So now let's see how we solve this question with the help of a code. Okay, so let's see. So what we have been given a, a function make largest special with the special binary string, which is a string s. Okay, this we have been given. Now let's see what we'll do in our code. So first what we'll check the edge case. If our string is empty, we'll return it. So this edge case we'll check, then simply we'll return our string. Next thing what we'll check if, like now what we'll do, we'll define our vector in which we'll carry our substring which we need to swap. Okay, and what else we can take, we can take a counter variable in which we can count the number of ones and zeros to check if number of ones are greater than number of zeros. Okay, so these two variables we'll take. Okay, now what we'll do, we'll iterate through this string s. How will a string, how we'll do that? For n I equal to 0, we'll take another variable in which we'll check for the previous index. So we'll take j equal to 0 and we'll move this till I is less than s dot size. and I plus plus. Okay. Now what we'll do inside this loop, we'll update our count variable first. Okay. So this counter variable, what it will does, it will add +1 if our string is 1, else it will add -1. So what we are doing here, let's see. We are checking if our number of ones are greater than 0. So if it is 1, it will be +1. So means our 1 is there. Again 1 plus 1, again 1 plus 1. As we enter a 0, we'll do a -1. So we know how many ones are in our left positions. Okay, that's what we are doing over here. Let's continue with our code. Okay. And if at any point if our counter variable becomes 0, that means we'll swap that string, which is answer dot push back. We'll add it in our vector, that substring. Okay. How we'll do, we'll again call this make largest special function. Now by sending the substring which will start from j plus 1 comma I minus j plus 1. Okay, and at last we'll append a 0. Don't worry, I'll tell you what we have done over here. Okay, and what we'll do, we'll update our j variable with I plus 1. Okay, and after this for loop, what we'll do, we'll sort our answer to see the lexicographically biggest answer. Okay, because we want only one answer which is lexicographically bigger than any of other answers. Okay, so we'll sort them in decreasing order. Okay, and finally we'll return accumulate answer. Okay, so we'll finally return our hence formed special binary string. Okay, now let's see what we have done in our for loop when the count has become 0. Okay, so what we have done over there is, this was the core logic of our entire. So what happens here for our 1 to 0 positions? Okay, when number of ones are equal to number of zeros, then our counter variable has become 0. Okay, so what we have done, we have again sent this to our we have again sent this substring to our function, so that to make it recursively largest by doing that operation. Okay, and how we have done, we have written the s dot substring from j plus 1 comma I minus j minus 1. Okay, why we have done here, we have removed the outer 1 and 0, and we have only considered the inner ones and zeros. Okay, and then what we have done, we have rebuilt this by adding 1 and 0. Okay, that's what we have done. we have sent this function, and what it returns, we have added 1 and 0 in it. Okay, got it? So let's take an example. Suppose our s is equals to 110110000. Okay, so let's split it into the top strings. At last, what we'll have count equal to 0. Okay, when the counter will be here. Okay, number of ones will be equal to number of zeros, so our counter will equal to 0. So what we have done over here, we have removed this one and this one, and what we have written is our inner. This one we have again sent it in the recursive function. Okay, now this will again split into two parts, which is 10 and 110. Okay, got it? Now we'll sort it. Okay, what after sorting, what it will be? 110 and 10, because when we call this function, it will go to this point, and then it will sort this, and finally it will return this one. And when it will return, it will return this sorted string. Okay, and while rebuilding, we have added our 1 and 0. Okay, and while we have added this 110, our finally string would have become 1100100. And this was our answer. See, this was our given string and this was our answer. Okay, so this is how we have done. Okay, this is a hard level problem. If you didn't understand this problem, go through it again and again, and first solve problem like valid parenthesis, and understand the concept of grading, sorting, and divide and conquer, like these. And then come back to this question, and then you'll understand it more deeply and understood what this problem says. Okay, and what's the time complexity of this code? It is of n log n. Okay, so that was it. If you have any doubt or any suggestions, just put it in the comment section, and keep learning, keep growing. Bye bye.